Hello and welcome. I'm James Murphy from mCoding, and today we're talking about data classes. Data classes are a bread and butter tool for the everyday programmer. It can save you literally hours every week of writing boilerplate code. Instead of just showing you the syntax, let me show you the struggle that you would have to go through if you weren't using data classes. Imagine you're working on a small to mid-sized project. Maybe there are other contributors on a GitHub project, or maybe this is for work and you're working with your coworkers, or maybe you just want to have good code style for yourself. Just for example, let's assume you're working on a web app and people can comment. So far in your project, comments have basically just been like a tuple of a unique index and the text content. Or maybe you're just using dictionaries with ID and text keys. But in any case, the project is starting to get to a point where it's a little bit too big to just have raw tuples floating around. So you decide, for sake of readability, you're going to make comment into a class in its own right. Let's see all the work that you would have to do just to write a simple comment class that is a wrapper around literally just an integer and a string. Well, of course, we have to write an init function. That's pretty boilerplate, but not too much work. And people are going to want to print these things out from time to time, so we'll write a repr just to make things nice for people. And it's always good practice to write an equals function. But for type safety, we should probably make sure that we're not comparing ourselves with things of different classes. We don't have to write a not equals, but it does improve code performance a little bit, so let's go ahead and do that as well. Ooh, I can definitely see someone wanting to put one of these things inside a dictionary, so that means it needs to be hashable. We need to write a hash function. And if something's going to be hashable, we should really make it immutable as well. To make it immutable, I just replace the ID and text with double under ID and text, and then make ID and text properties, so that way people can read those properties, but they can't write to them. Oh, and what if someone wants to sort these things? Well, then I need to write a less than or equal to, a greater than, and a greater than or equal to method. Now this is really starting to get out of hand. Okay, I know the functools library has this thing called total ordering, so really I only have to write one of those and then slap this class with a total ordering. So if I just write the less than and use total ordering, then that will write the less than or equal to, the greater than, or the greater than or equal to. But total ordering is a little bit slower, so just for speed, I should probably go ahead and write those all myself. Okay, that was a little bit more work than I really wanted to put in, but it's done, it's over. This class is perfect, right? Oh, wait, comments have authors. I need to put the author ID in this class. So now I gotta add it here. Then I need to make another property, and then I need to change this and put it in here and put it in here and here and here. And just to make one little change, I now have to rewrite the entire class. I don't want to do that. Even if I was willing to put in the work, there's a pretty large chance that I would miss one of the places and then have a broken class. There's got to be a better way, right? Enter data classes. Take all that code and delete it. Here's the implementation of that class now. So now I can construct a comment just as usual, pass it its arguments, 1 and I just subscribed. And I can print it out. And you can see it has a nice repr, and I would just use this as I would a normal class. Of course, if I ever did need to convert it into a tuple or a dictionary, data classes has an asTuple or asDict function, which will convert for you. So let me just print those out. You can see it'll give it back to me as a tuple or a dictionary if I really want that. But for now, let's just assume that we're just going to be using the class. So to take a look at what data class has actually done for me, I'm going to be using the inspect module, which allows me to look at what are all the functions that are now written in this class. So when I print them out, you can see that equals, greater than, all these things have all been written for me. And they've all been implemented correctly. There's no chance of missing a self dot or switching the order of some arguments or something like that. By default, if I didn't have those frozen or order arguments, then you would see this. By default, it just writes the equals, init, and repr. If you want it to write the hash, then it needs to be immutable. So you do that by saying that frozen equals true. You can see that it added a hash function, and it also added a setAttr, which is necessary to make it immutable. So now if I try to say comment.id equals 3, well, first off, PyCharm already knows it says this ID is read-only, And if I try to run the code, I'll get a frozen instance error, so it's not allowing me to change that ID. Of course, if you don't want your data structure to be immutable, it doesn't have to be. I think the order keyword argument is pretty self-explanatory. If I just added that one in, then it would just write all the things that the total ordering method would write. But notice here, I didn't have to write less than. It wrote all of them for me. So the order that it's actually creating is the same one that you would get for a tuple that has its arguments in this order. Generally, I do think it's a good idea to make most data classes frozen so that people can use them as keys in dictionaries. If you want to make a copy of an immutable data class with something changed in it, then you can use the replace method from the data classes library. You can also set default values like this, so that if I leave off an argument, it just gets that default value. Now, as usual, you always want to watch out for default mutable arguments. In this case, we do not want every instance of the comment class to share this same list. The way to avoid that is by using a default factory, so that every instance should call this function with no arguments in order to create this attribute if it wasn't passed in. Notice here that I'm using this field method from the data classes library. This is actually what's being used in all of these cases behind the scene. So in reality, this is equivalent. In very simple cases, in most cases, I think you can leave off the field and just use the simpler syntax of before, but in classes that have more attributes, you're going to find yourself wanting to use this. This field function takes other arguments which can allow you to modify how each attribute acts with respect to things like the order and the hash. So I can do something like compare equals false to prevent replies from being compared when you compare two comments. Similarly, I might not want it to participate in the hashing or show up when I print it. So you can see that when I print it out, it still just shows ID and text even though the replies field is there. So that's data classes and how to use them, but I do also want to mention a very similar library. In most cases, data classes do everything that I need. But I do want to at least mention another library, the adders library, that data classes were actually based off of. The adders library does essentially the same thing that the data classes library does, except with slightly different names. Now I say attrib and adders instead of data class and field, but it also does a little bit more. In particular, adders allow you to specify validators to do something like actually check the type of something at runtime, or converters to convert something to a specified type. The last major feature that adders supports that data classes doesn't is the slots feature. So if you want your class to use slots instead of an instance dictionary, then adders supports that, but data classes doesn't. To me, there are only two real downsides to using the adders library. The first is that it does not support this bare syntax here. You do have to say equals adder.ib and equals adder.ib. Now, the one exception to this is that if all of your fields have a default value, you can use this syntax, but if any of them doesn't, then they all need attribs. And to me, the only other downside of using the adders library is that it is a separate dependency. It's not built into Python, so you do have to download it separately. If you're someone who worries a lot about including outside dependencies in your project, then adders would not be for you, but you could still use data classes. So that's my take on data classes and the adders library. They're going to save you a huge amount of time. I hope that you can work them into your workflow. If you liked the video, don't forget to give it a like, and if you especially liked it, please consider subscribing. Thanks for watching. See you next time.